variability. Variability means how much does it vary, meaning if it varies a lot, one of your data points might be 1 might be 100. If it doesn't vary very much, it would be one of your points might be 1 might be 6. So a measure of variability is a single value used to describe how spread out a set of data values are. The mean absolute deviation is a measure of variability. So there are 3 types of variability measures we're going to learn today. Mean absolute deviation, you've already learned, so we're going to do a little review on that. And then range and interquartile range we'll look at today. All right, unlock the problem. In gym class, the students recorded how far they could jump. The data set below gives the distances in inches that Manuel jumped. What is the mean absolute deviation? So it's asking, what is the mean absolute deviation? So that's what you should highlight. And then you need to be looking at this data, okay? To find the mean absolute deviation, the first thing we need to do is find the mean. And to find the mean, we have to add up all our values. So we have, should have wrote these before, 58, 54, 58, 56, 59, 60, and 55. There we go. And you're going to divide it by 6 because that's how many values there are. So after you add them all up, you would get 342. And 342 divided by 6 is 57. So the average or the mean of this data is 57 inches. So that means he typically will jump about 57 inches. So that is the mean. Now we need to find the mean absolute deviation. And then to find the mean absolute deviation, we need to find the distances from the value to the mean. So our first data value was 54. From 54 to 57 is 3. Our second data value is 58. From 58 to 57, it's 1. Then 56, so 56 to 57 is 1. 59 to 57 is 2. 60 to 57 is 3. And 55 to 57 is 2. Add those up, so you have 3, 4, 5, 7, 10, 12. So that is the total distances. Then to find the mean absolute deviation, you take the distances and divide it by 6, because that's how many you added up, and you get 2. So the mean absolute deviation of this set of data is 2. If you remember, we talked a little bit yesterday about the bigger the mean absolute deviation, the more spread out your data is. All right, so mean absolute deviation is one way to check the measure of variability. Then we have the range and interquartile range. So range is just the biggest minus the smallest. Interquartile range is the upper quartile minus the lower quartile, okay? So let's look at the example. The box plot shows the price in dollars of the handheld game players at two different electronic stores. Find the range and interquartile range for each data set, then compare the variability of the prices. So it's telling us to find range and interquartile range of each data set and then compare. Okay? So let's look at store A. So what store A is saying is the most expensive handheld game they have there is $150, and the cheapest is $24. The average price is 52. The upper quartile looks to be like 72, and the lower quartile is 48. So to find the range, we take the biggest minus the smallest. So we have 150 minus 24, and when you subtract that out, you get 126. So the range for store A is 126. Okay? Interquartile range, we take the upper quartile minus the lower quartile. So we have 72 minus 48, and that gives us 24. So the interquartile range for store A is 24. Now let's look at the range for store B. So range is biggest minus smallest, so we have 120 minus 30. So our range for store B is 90. Then our interquartile range, we have the upper quartile minus the lower quartile, which is 42. When you subtract those out, you get 58. So the interquartile range for store B is 58. So now if we're looking at the ranges, store A has a greater range, but if you look at interquartile range, store B has the greater interquartile range. I'm just going to abbreviate it with IR. Okay, so those are the three ways we check for variability. Looking at share and show on the next page. Number 1, find the range and interquartile range of the data in the box plot. Okay, so the range is the biggest minus the smallest. It looks like your greatest value there is 19. And then your least value, it looks like is 5, 6, 7. So your range is going to be 12. And then we have our interquartile range, which is the upper and lower quartile. So the upper quartile is 15, and the lower quartile is 10, 11, 12. So the interquartile range is 3. Okay. All right, now we can look at number 2 and 3. It says find the mean absolute deviation. I'm going to do it with a text box just because I think it might be quicker. Okay, so the mean absolute deviation. So the first thing we have to do is find the mean. So the mean, oops. Oh man. There we go. So we add up all of our values. So we have 16 plus 18 plus 18 plus 20 plus 17 plus 20 plus 18 plus 17. You of course can use your calculator, which is what I'm going to do. So 16 plus 18 plus 18 divided, or plus 20 plus 17 plus 20 plus 18 plus 17 gives me 144. Okay, and then you're going to take your 144 and you're going to divide that by, how many did we add up? 1, 2, 3, 4, 5, 6, 7, 8. And you should get 18. So the average is 18, or the mean. So then the mean absolute deviation, we have to find the distances of all of your data to your mean. So from 16 to 18 is 2, from 18 to 18 is 0, 18 to 18 is 0, 20 to 18 is 2, 17 to 18 is 1, 20 to 18 is 2, 18 to 18 is 0, and 17 to 18 is 1. When you add all those up, 2, 4, 6, 8, you get 8. And we have 8 divided by, how many did we add up? 1, 2, 3, 4, 5, 6, 7, 8. 8 divided by 8, so your mean absolute deviation is 1. Okay? So of course you would then go and write it right here. Okay, let's look at number 3. Okay, so first we'll find the mean. Oops. So we're gonna add them up. So we have 68 plus 60 plus 52. Oops, whoa. Get rid of that. So 60 plus 52 plus 40 plus 64 plus 40. You're gonna add those up. So 68 plus 60. 52 plus 40 plus 64 plus 40. You get 324. You're going to take 324 and divide it by 1, 2, 3, 4, 5, 6. And your mean is 54. Then we need to find the mean absolute deviation. So find the distances to the mean. So from 68 to 54, it's 14. From 60 to 54, it's 6. 52 to 54, it's 2. 40 to 54, it's 14. 64 to 54, it's 10. 40 to 54, it's 14. Okay, add those up. You should get 60. Then 60 divided by how many you added up, which was 6. Your mean absolute deviation is 10. Okay, and then you would go write it up here. Now if somebody were to ask you which data set varies more, number 2 or number 3, it would be number 3 because the mean absolute deviation is much bigger. Okay guys, the rest is on your own. If you have questions, log into Teams for our team meeting to ask the questions. Have a good day.